Students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing the numericals of electrostatics. Please take down. A circular metal plate of radius, 10 centimeters, a circular metal plate of radius 10 centimeters is given a charge of 20 microcoulombs, Determine the outward pull on the plate. If epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square, and K is 1. Now guys, since this is a circular plate, what will be the area of the circular plate? The area of the circular plate is going to be pi r square. Fine? Okay. Force is nothing but sigma square upon 2 epsilon 0 k ds. Now I don't think they have given us sigma square. That's your charge density. Now what is charge density? How do I define charge density? By definition, charge density is nothing but charge upon area. By definition, charge density is nothing but charge upon area. That is charge upon area. So in that case, if I substitute this here, I can therefore say that F, instead of sigma square, I can write Q square upon ds square 2 epsilon 0 k into ds square, and ds gets cancelled. I'm deriving the formula, guys. F is equal to Q square upon 2 epsilon 0 k ds Q epsilon 0 k ds pi r square. Yes, I have all the values. Since I have all the values, I can find this answer. The answer for this sum should be 719.7 newtons. Next, take our next up, please. A metal surface of area 1 meter square. A metal surface of area 1 meter square is charged with square root of 8.85 microcoulombs. A metal surface of area 1 meter square is charged with square root of 8.85 microcoulombs. In air. Calculate the mechanical force acting on it. If epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Force sigma square upon 2 epsilon 0 k ds, but sigma is nothing but Q upon ds. Substituting, if I substitute, I will get F is equal to Q square upon 2 epsilon 0 k ds the whole square into ds. So F is equal to Q square upon 2 epsilon 0 k ds. Right? Once you have this, you have all the values. You have ds, you have Q, epsilon 0, k is not given to you.
So it is assumed to be 1.
Yes, it is going to be assumed to be 1. Yes, I know. It is going to be assumed to be 1 because it is air. Right? Because they said that it is charged with square root of 8.85 microcoulombs in air. So since it is in air, K is going to be equal to 1. So you will get your answer. You have all the values. You can substitute and get the answer. the answer for this sum should be 0.5 Newton. Next, let's see another sum, guys. Calculate the outward pull. Calculate the outward pull on a metal plate. Calculate the outward pull on a metal plate of 0.01 meter square having a charge density of 100 microcoulombs per meter square, having a charge density of 100 microcoulombs per meter square if it is kept in air and epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. K is going to be equal to 1, right? Same formula that we've been using in the previous two sums. You will still have the same formula, sigma square. Here fortunately for us they've given you sigma 2 epsilon 0 K into ds, epsilon 0 K ds sigma. All the values are given to you. Simple multiplication, you should get this answer as 5.65 newtons. Next, take on next one, please. An isolated conducting sphere. An isolated conducting sphere of
The ds should be in denominator.
which
The f is equal to sigma square to epsilon naught k ds.
sigma square.
Because f is equal to q square to epsilon naught ds.
F is equal to sigma square to epsilon 0 k ds. If it is q square. If it is q square, then the ds is in the denominator. If it is sigma square, then the ds is in the numerator. Right? Okay. Let's move on to the next one. An isolated conducting sphere of radius. An isolated conducting sphere of radius 0.1 meter is placed in vacuum. An isolated conducting sphere of radius 0.1 meter is placed in vacuum and carries a positive charge of 0.1 microcoulombs. Find the electric intensity at a point. Find the electric intensity at a point. Find the electric intensity at a point at a distance of 0.2 meters. 0.2 meters from the center. If 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 Newton meter square per coulomb square. Right? Now, electric intensity is given by the formula Q upon 4 pi epsilon 0 K R square. Q is given to you, the distance is small r is given to you, 1 upon 4 pi epsilon 0 is given to you. Since it is air, K is going to be equal to 1. All the values are given to you, straightforward multiplication and division. You should get this answer as 2.25 into 10 raised to 4 newtons per coulomb. Next, a uniformly charged sphere a uniformly charged sphere produces an intensity, a uniformly charged sphere produces an intensity of 100 volts per meter, of 100 volts per meter in a medium of dielectric constant 5, in a medium of dielectric constant 5. Calculate the surface charge density. Calculate the surface charge density. Calculate the surface charge density. Now guys, we know that E is equal to Q upon 4 pi epsilon 0 k r square. Right? Now, let's try to reframe this. E is equal to Q upon epsilon 0 k, or let's write this up. 1 upon epsilon 0 k, epsilon 0 k, that will give you Q upon 4 pi r square. But what kind of a object am I using? I'm using a sphere, right? Now we also know they've asked me to calculate surface charge density. Surface charge density. Sigma is charge upon area. So surface charge density is going to be charge, that is Q, upon area. Since it is a sphere, the surface area of the sphere will be 4 pi r square, right? That means Q upon 4 pi r square. Now I can substitute as sigma. Hence I can say E is equal to 1 upon epsilon 0 k into sigma, right? I have E, I have K, right? Epsilon 0 value, I know by heart. Epsilon 0 is nothing but 8.85 into 10 raised to minus 12 SI units. So I know epsilon 0, I know K, I know E, I should be able to get the value of sigma. Right? Answer, you should get sigma is 4.425 into 10 raised to minus 9 coulombs per meter square. Next, let's see the next one. The electric intensity at a point, the electric intensity at a point, the electric intensity at a point at a distance of 1 meter, at a distance of 1 meter from the center of a sphere, from the center of a sphere of radius 25 centimeters, radius 25 centimeters is 10 to the power of 4 newtons per coulomb. Find the surface density of the sphere. Find the surface density of the sphere if the sphere is situated in air. If the sphere is situated in air and epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Let's see this. First, let's find out the surface area of the sphere. Surface area of the sphere is going to be nothing but A, which is nothing but 4 pi r square. Right? Now, once I know the surface area of the sphere, I can say electric intensity is nothing but Q upon 4 pi epsilon 0 K r square. Right? So in which case I could say that Q is E 4 pi epsilon 0 K r square. Right? Once I have this, they have asked me to find out the surface density of the charge. Now surface density by definition, surface density of charge by definition is nothing but charge upon area, that is Q upon area. Q we just found out is nothing but E 4 pi epsilon 0 K r square. Area, right in the beginning of the sum we found this as 4 pi r square. So 4 pi gets cancelled, in which case you will get surface density. You will get surface density is equal to E epsilon 0 K r square upon r square. So you should be able to get this answer now. You have E, you have epsilon 0 K, small r and capital R. The answer for this sum should be 1.416 into 10 raised to minus 6 coulombs per meter square. Next, take down next one please. The charge density on the surface of a conducting sphere, the charge density on the surface of a conducting sphere is 128 into 10 raised to minus 7 coulombs per meter square. And the electric intensity at a distance of 4 meters from the center of the sphere is 8 pi into 10 raised to 4 newtons per coulomb. What is the radius of the sphere? What is the radius of the sphere? Let us assume that R is the radius of sphere. That means I can say that area of sphere A will be nothing but 4 pi r square. Area of the sphere will be 4 pi r square. Now, I can say that replica of the previous sum, electric intensity is Q upon 4 pi epsilon 0 K r square. Hence, I could say that Q is nothing but E 4 pi epsilon 0 K r square cross multiply. Right? Now, in this case, I could say that but charge density by definition is nothing but charge upon area. So in that case, that's E 4 pi epsilon 0 K r square upon 4 pi r square. 4 pi gets cancelled. So in which case you will get this as sigma is equal to E epsilon 0 K r square upon r square. Now let's see what else have they given you in the sum. The charge density on the surface of a conducting sphere is this much, electric intensity is this much, find this from the center of the sphere is this much. That means we can assume that the conducting sphere is in air, so I can take the value of K as 1. The value of epsilon 0, I know the value of epsilon 0 by heart. I can say epsilon 0 is 8.85 into 10 raised to minus 12 SI units, right?
So,
Excuse me?
my
That's a constant value. Epsilon 0 is a constant value, right? So you could substitute these values and get the answer. The answer for the sum should be that the radius of the sphere should be 1.667 meters. Next, take a next up please. A conducting cylinder of length 2 meters. A conducting cylinder of length 2 meters has a charge of 100 microcoulombs. Has a charge of 100 microcoulombs and is surrounded in a medium of dielectric constant 3 and is surrounded in a medium of dielectric constant 3. Find the electric intensity. Find the electric intensity at a distance of 3 meters. At a distance of 3 meters from the axis of the cylinder. Find the electric intensity at a distance of 3 meters from the axis of the cylinder. Now, they've given you that a conducting cylinder of length 2 meters has a charge of 100 microcoulombs. In that case, what will be my charge per unit length? That's my total charge. So my charge per unit length will be nothing but Q upon L. That's 100 into 10 raised to minus 6 upon L. That's 2. So my charge per unit length is going to be, the total charge is 100 microcoulomb. And this total charge of 100 microcoulombs is distributed over a length of 2 meters. So charge per unit length will be charge upon the length. Now, electric intensity is given by the formula Q upon 4 pi epsilon 0 kr square. I have all the values. Q I have, K I have, epsilon 0 I know by heart. Epsilon 0 is 8.85 into 10 raised to minus 12 SI units, right? So in which case you will get the value of epsilon 0, right? Now, once you have this, you can substitute and get the answer. The answer for this sum should be 10 raised to 5 newtons per coulomb. The answer for this sum should be 10 raised to 5 newtons per coulomb. Next, take on next up please. A conducting cylinder has a charge density. A conducting cylinder has a charge density of 0.121 microcoulombs per meter square. 0.121 microcoulombs per meter square. A conducting cylinder has a charge density of 0.121 microcoulombs per meter square and a radius of 25 millimeters in a dielectric constant of 4. the electric intensity, find the electric intensity at a distance of 1 meter from the axle of the cylinder. Find the electric intensity at a distance of 1 meter from the axle of the cylinder. Now since this is a cylinder, what will be the surface area of the cylinder? Surface area of cylinder. Surface area of cylinder is going to be nothing but A is nothing but 2 pi r L. That's going to be my surface area of the cylinder, where we will assume L to be the length of the cylinder. Therefore, what will be the total charge of the cylinder?
So we are considering only the curve.
Yeah. Right? Surface area, na? Therefore, I will.
So what about this?
No, I'm considering the curved surface area, not the total surface area. Now, what will be the, because I cannot consider the total surface area, Gaussian theorem says that lines of force pass perpendicular to the curved surface area. They cannot pass through the upper and the lower circle, right? Now, the total charge on the cylinder is going to be charge into area, right? If this is the total charge of the cylinder, in that case, what will be the charge per unit length? The charge per unit length, the charge per unit length is going to be total charge upon length. Total charge you found out is nothing but sigma A upon L. A you found out is 2 pi RL, sigma into 2 pi RL upon L. L and L gets cancelled, therefore the charge per unit length is going to be 2 pi R sigma. Fine, do we get this thing here? Now, once I have this, then I can find out my electric intensity. How do I find out electric intensity? Electric intensity is Q upon 4 pi epsilon 0 k R square. Q you have already found out as 2 pi R sigma upon 4 pi epsilon 0 k R square. Pi and pi gets cancelled, so you will get R sigma upon 2 epsilon 0 k R square. I know the radius of the cylinder, I know the distance at which I want the electric intensity. Sigma is given to you, epsilon 0. Epsilon 0 we know by heart is 8.85. 8.85 into 10 raised to minus 12 SI units. K is nothing but 4. So in that case you should be able to get the electric intensity. The electric intensity here should be 85.45 newtons per coulomb. Next, take our next one please. A conductor having a charge density, a conductor having a charge density of 120 microcoulombs per meter square, having a charge density of 120 microcoulombs per meter square, is kept in a dielectric constant 3. Find the electric intensity. Find the electric intensity at a point near the conductor. Find the electric intensity at a point near the conductor. Now we know that the value of epsilon 0 is 8.85 into 10 raised to minus 12 SI units, right? Now electric intensity at a point near the charged conductor is sigma upon epsilon 0 k, right? So in that case, this is going to be equal to, you have sigma, you have epsilon 0 k, straight multiplication. Answer for this sum should be 4.52 into 10 raised to 6 newtons per coulomb. Next, click on next one please. A uniformly charged sphere, carries a total charge of 2 pi into 10 raised to minus 12 coulombs. Its radius is 5 centimeters. Determine the charge density. Now, the given body is in spherical form. Therefore, what will be the surface area of sphere? The surface area of sphere will be 4 pi r square. Charge density, by definition, is given by the formula charge upon area. So charge density is charge upon area, 4 pi r square. Q I have, 4 pi r square I have. I should be able to get the answer. The answer for this sum should be 2 into 10 raised to minus 10 coulombs per meter square. Next, let's see the next sum. Calculate the energy per unit volume. Calculate the energy per unit volume of a medium. Calculate the energy per unit volume of a medium of dielectric constant 3 if the intensity of electric field is 100 volts per meter. If the intensity of electric field is 100 volts per meter, they have asked you to find out energy per unit volume. Energy per unit volume. Energy per unit volume U is half epsilon 0 k E square. We have done the derivation. Epsilon 0 k E. All the values I have. Straight away I can find out. Answer for this sum should be 13.275 into 10 raised to minus 8 joules per meter cube. Right? Okay, we'll stop this here for the day. Thank you very much.